Okay, we are doing yet another section from 9.4. Today is not going to be a whole lot different from days 1 and 2, but today we are going to divide rational expressions. So that just changes our steps just a teeny tiny bit. So let's fill in those notes, and then we just got a bunch of examples. Remember that when you divide fractions, you must multiply by the reciprocal of the divisor, which is also known as the second fraction. The same is true when dividing rational expressions. Once division is changed into multiplication, follow the rules for multiplication learned 2 days ago. It says yesterday, that's fine. We learned it 2 days ago, we practiced it yesterday. We'll just put previously. You don't actually have to write that part down. Just fill in your blanks and your notes will be complete. Here we go. I'll go ahead and put up 1 and 2. So before I do anything else, my very first step is going to be to change these into multiplication problems. Be a second to finish writing down at least number 1. Okay, so before I worry about anything else, anything at all, I want to change this into a multiplication problem. So my first fraction is going to stay exactly the same. 7x over 4y cubed. My second fraction, I need the reciprocal, which means I do what? Flip it. So on the numerator, I now have an 8y. On the denominator, I now have a 21x cubed. That's got to be our first step anytime we've got a division problem with rational expressions. After we do that, then it's just like what we've been doing before. Now this problem is something that we would have seen on 9.4 day 2. So we're just looking for what we can reduce or cancel out before we multiply straight across the top and straight across the bottom. 4 and 8 can reduce. What does the 8 become? 2. 4 becomes 1. Anything else? 7 and 21. What does 7 become? 1. 21 becomes 3.
So you can't reduce the letters?
We can. We just haven't gotten there yet. What letters do you want to reduce? Okay, let's do the x's first. What are we left with? Nothing on the top.
X squared.
X squared on the bottom. Good. Remember that it goes wherever the bigger exponent started. And what about our y's?
It just becomes 1.
For 1 or y to the first power on the bottom.
Y to the second power, right? So I know this 2 that I wrote when I crossed off the 8, it does not belong on the y. That was just from me crossing off the 8. I just didn't have enough room to write it all the way above it. Okay, so this y did not start off with an exponent. It was a y to the first. So we do end up with a y squared, and it goes on the bottom. Now, if it's hard to see what's going on here, we can just go ahead and rewrite what's left. You've got 1 over 1y squared times 2 over 3x squared. You don't necessarily have to write out that step, but if you're not sure what you got left, that might be useful. So now we just multiply across the top, multiply across the bottom. 1 times 2 is 2 over, what's in my denominator?
3x squared y.
Squared.
Good. 3x squared y squared.
Oh.
And then we're done. So the only thing that's really different about what we're doing today is that very first step of switching it to be a multiplication problem. So on number 2, when I go to set it up, I'm going to have 2 fractions. My first fraction is going to stay the same. 3x cubed over 5y squared. My second fraction is going to flip around or switch. 5y cubed over 6x to the 5th. Keep your first fraction, change your sign, flip your second fraction. Okay, now we're ready to cancel. What do we want to cancel?
3 and 6.
3 becomes,
1.
6 becomes,
2.
good. What else?
5.
What happens to the 5s?
They turn into a 1.
They both turn into 1. So you can either just cross them off. You can put the little 1s by them if you want to. But they totally cancel each other out. What else? The x's. So we've got x cubed on top, x to the 5th on the bottom. X squared will be on the bottom. Good. And the y's, what are we going to be left with? 1y on the top. Y to the 1st. So I crossed everything off down in this denominator. What's left there? A 1 in this denominator. So if you're not sure, you can just go ahead and put a 1 there if you need to see something there. So let's just go straight to our answer. 1 times y is just a y over 1 times 2x squared. 2x squared. Now when you do these, in case anyone was wondering, I do need you to go ahead and write out your final answer and make clear that that is your final answer. Circle it, put a box around it. If your work is nice and organized and I can tell that that's your answer, that's fine. But don't leave it this jumbled mess, even though nothing really changed, right? 1 times y was y. Nothing changed here really, but I need a nice clean answer. Questions before I put up a couple more? Okay, we'll just keep going. Now on these next two, my first step is going to be the same. My first step is going to be to rewrite the problem as a multiplication problem. But after that, things will be a little bit different from those first two. All right, first step, we are going to rewrite these as multiplication problems. We'll start with number 3. My first fraction is going to stay the same. 6x plus 6y over x minus y. My second fraction is going to flip. So the 5x minus 5y goes to the top. 18 goes to the bottom. What here can get factored? Good. This numerator and the other numerator. Both of my numerators can get factored, but neither of my denominators can. So if we set up our fractions again, I know for a fact that my denominators are staying the same for now, and I have to factor my numerators. What can I factor from my first numerator? A 6. What's left?
6 minus y.
Careful. Good. X plus y. And my other numerator, what can I factor? Getting ahead of me. I can factor a 5. What's left? X minus y. Okay. After we are done factoring, now we can simplify or cancel things out. What can cancel out?
X minus y.
Good. Remember down here, this x minus y, even though they never wrote it in parentheses, those are stuck together. So we can cancel out those.
6 and 18 can simplify.
Good. 6 and 18. Simplify. 6 becomes 1. 18 becomes 3. I believe that is all we can simplify. So we've got x plus y times 5.
5 x plus y.
Good. We write that as 5 times x plus y.
3.
All divided by 3. Good. The only thing left down there is 1 times 3, which is 3. Questions about number 3? All right, why don't you try number 4 if you have not already done so. Remember, the first thing you should do is switch it to be a multiplication problem. Do not start factoring before you do that. You might get tempted to cancel out things that you shouldn't. So just do your first step of rewriting it as a multiplication problem first. All right, the first thing that we did was flip the second one. So rewrite it. 3. I'm going to switch colors so we don't get confused. 3y minus 12 over 2y plus 4 times, what did we do to that second fraction?
4y plus 8
4y plus 8.
over 6y minus 24.
Good. Flip the second one. After we do that, we are ready to factor. Good. Which in this case means we're looking for GCFs. So, all right. Top left. GCF is 3. We're left with y minus 4. Okay. Top right.
4
Times.
y plus 2.
Beautiful. Bottom left.
2
Times.
y plus 2.
Okay. And last one.
6 y minus 4.
Y minus 4. Okay, we all agree with the factoring step.
That's easy.
Okay. What's canceling out?
4 and 2.
Let's do what totally cancels
Okay.
first. Just for the fun of it. The y minus 4s are totally gone.
Y plus 2.
Y plus 2s are gone. So you can handle this a couple ways. Either you can keep cross reducing, or you can just go ahead and multiply what you've got and see what happens. So I think in this case, since we're done with all of those parentheses, it might be easier to just go ahead and multiply. So we multiply straight across the top. 3 times 4 is 12. 2 times 6 is... So our answer is 1. Big ol' 1. My first step should be to flip my second fraction. So we are going to rewrite the whole problem as a multiplication problem. What's happening to my first fraction right now? Stays the same. X squared over... I'm not going to factor yet. I'm just going to x squared plus 2x plus 1. I don't want to do anything until I flip my second fraction. So my second fraction becomes x squared minus 1 over 3x. All right, now I am ready to start factoring. So I'm going to set up another set of fractions. My first numerator stays the same. Monomial, nothing to factor. My other numerator. Good. Difference between two perfect squares. X plus 1, x minus 1. My first denominator.
X plus 1, x plus 1.
Beautiful. Remember on those we need to multiply to the number in the back, add up to the number in the middle. And my last denominator stays the same. Okay, what now?
Cross out the x plus 1.
And the other x plus 1. Okay, so we cross out a pair of x plus 1s.
That's it.
That's not it.
Simplify x.
Good, we can simplify these x's.
Oh.
So the becomes what?
X.
X on the top.
And then
Now we're done with our canceling or reducing. We have questions about the factor step or the cancel step. Okay, so we are ready to write our answer. What do I have in my numerator? Good, x times x minus 1. And in my denominator?
3 times x plus 1.
Beautiful. 3 times x plus 1. We need to flip our second fraction, so I'm going to rewrite this. First fraction staying the exact same. I am not going to have room there. Let me move it down here. Y squared minus 5y plus 6 all over y cubed times my second fraction, 4y squared.
4 squared plus 31 minus 10.
Beautiful. Second fraction flips, first fraction stays. Now, after we are done flipping our second fraction, we are ready to factor. First numerator factors into y minus 2, y minus 3. Good. Did not give myself enough room this time. All right, what about my other numerator? It stays. It's a monomial. It cannot be factored. My first denominator also stays. Monomial can't be factored. And my second denominator.
4 plus 5, y minus 2.
Beautiful. Y plus 5, y minus 2. We're multiplying to a negative 10, adding up to a positive 3. Now that we are done factoring, we can cancel. All right, what's canceling out? Y minus 2s. What else? The y's. What are we left with? Y to the first in the denominator. Anything else? What about these y's? Oh, good. This one up here is trapped in parentheses. It cannot cancel out with the lonely y down here. Okay, so we write our answer. What's in my numerator?
4y
4 minus 5 minus 8.
Good. My denominator?
y times
Y times 5 plus 5.
Beautiful.
Oh, I didn't do it wrong.
All right, on number 7. First thing I do is rewrite it as a multiplication problem. So my first fraction is going to stay exactly the same. My second fraction is going to flip. So the x squared minus 64 moves to the top, x plus 8 on the bottom. After we have rewritten it as a multiplication problem, we are ready to factor. Anybody find my factors for my first numerator?
x plus 8, x plus 2.
Very good. X plus 8, x plus 2. Multiplying to a 16, adding up to a 10. What about my second numerator?
X plus 8, x minus 8.
X plus 8, x minus 8. That's the difference of two perfect squares. My first denominator. Good. X minus 8, x plus 2. So again, multiplying to a negative 16, adding up to a negative 6. My last denominator stays the same. X plus 8. I'm going to put parentheses around it to remember it's stuck together. Now we are ready to simplify. What can cancel? Okay, everything but an x plus 8. So the x plus 2's, top and bottom, they go away. These x plus 8, x minus 8, top and bottom, go away. Over here, x plus 8, x minus 8, top and bottom, go away. So all we're left with is an x plus 8. We could put it over a 1 if you want to, but you don't have to. You can just write it as x plus 8. You can put the parentheses or you can leave them off. Doesn't matter to me. We good with 7? Okay. Oh, here it is. We predicted the future. We are going to have to use our bubble method on a couple of these when we get to the factoring part. All right, same old story. Our first step is to rewrite it, but we are going to do what? How's it going to change just a little bit? We are not ready to factor.
Reciprocal.
We got to use the reciprocal of which fraction? The second one. First one we leave alone. Second one we flip. So we are going to have to use our bubble method 2 times. You don't have to use it everywhere. So for example, our first numerator, we don't need to use the bubble method. How is our first numerator going to factor?
X plus 1, x minus 2.
Good. X plus 1, x minus 2. Where else do we not need the bubble method? Good, the second denominator. So why don't we go ahead and just fill that one in? What's going in our second denominator? Good, x minus 4, x plus 3. So I just went ahead and filled those in because those are quick to factor. We don't have to use the bubble method. Okay, where do we want to start? Do we want to do our denominator or our numerator first? Denominator? I like doing the denominator. It doesn't really matter. We got to do them both eventually. So let's use this denominator first. That's going to be my first focus for the bubble method. I only have one option for my first bubble. What does it have to be?
1 and 2.
A 1 and 2. Now, my second bubble, I only have one option for factors, really. What are my only options to multiply to a 2?
1 and 2.
1 and 2.
But
But we got to watch our signs. They're both negative. Okay, if we want to multiply to a positive, they have to have the same sign. But we know that eventually we want to add up to a negative. So they're both negative. Are you sure that's where you want them?
Oh, well, you just look at them on. So.
Oh, okay. So I want my 1 to match up with the negative 1, and I want my 2 to match up with a negative 2. Because when we do that, we multiply between our bubbles. So 1 times negative 1 is negative 1. 2 times negative 2 is negative 4. We add them together. We get a negative 5. That's what we wanted. So these bubbles help us write our factors in their parentheses.
1 x minus 2.
Good. What's my other one?
2x minus
2x minus 1. Good. So remember, when we go from bubbles to parentheses, we kind of switch what was connected. So the 1 from the first bubble gives me this 1x here. It had been connected to a -1, so we're going to switch it, and now it's going to be matched up with the -2. And then the same thing happens for this 2. That's what gave us a 2x, and it crossed over to get matched up with the -1. All right, now we've got to do bubbles for our last numerator. Again, what's my only option for my first bubble? 1 and 2. Now in my second bubble, I need numbers that multiply to what?
1 and 3. Oh, 5.
Multiply
3.
to, close?
Negative
A -3. I got to multiply to a -3, which means one of my numbers will be
Negative.
negative.
So 1 will be negative.
1 will be negative.
Okay, 1's going to be negative, 3's going to be positive.
3 is the other 2.
The 3 needs to match up with the 2. Good. Now, if you didn't see that ahead of time, you can do this like guess and check. If your bubbles don't end up working, then you can erase it and try something different. But when we do this, 1 times -1 is a -1. 2 times 3 is 6. When I add those, I get a 5. Are we okay with the bubbles? Okay, then let's use them to write our factors if I don't run out of space. What's one of my factors?
1x plus 3.
X plus 3. My other one is 2x minus 1. Lots of factoring on this one. What do we need to do next? What cancels?
X plus 2.
The x, the what?
X plus 2.
Minus
There
2.
is no x plus 2.
Yeah, there's no x plus 2. There is what? X minus 2. What else is there?
2x minus 1.
2x minus 1s.
1x plus 3.
1x plus 3s. Anything else? Nope. So what are we left with for an answer? What?
X plus 1.
X plus 1
Over x minus 1.
over x minus 4. Okay. Again, you can put them in parentheses or you cannot, as long as you do not try to cancel out these x's. Technically, they would be trapped with their binomial. I just want to real quick talk about what this down here means because we haven't really seen this for a while.
Or b plus 5, b plus 5.
Good. So when we go to rewrite this problem, it'll be the same thing. You're going to want to flip your second fraction. But when you get to your factor step, you need to know that this is b plus 5 times b plus 5. So I would not write it like b plus 5 squared the whole time. On your next step or on your factoring step, I would rewrite it expanded so that you know what to cancel out. Does that make sense? Okay, so we won't walk through this whole one. If you want to copy it down real quick, you can for practice. But and then the last one is going to be the same type of problem. And since we practiced a little bit yesterday, I think most people would be able to recognize how to factor this numerator. What are we going to factor from that numerator? 6x squared. Good. So yesterday, a few people forgot that your GCF sometimes is just a variable piece. For example, in this denominator, what's our GCF? X cubed. Okay, so just be aware of that. Sometimes your GCF will include or it'll only be a variable part.